So here we have a right triangle with an angle theta, and we have the opposite side, the adjacent side, and the hypotenuse. So here we have the six trigonometric ratios. Sine is opposite over adjacent. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Cosecant is hypotenuse over opposite. So remember, 1 over cosecant equals 1 over sine. So that means that we flip which way they go. Similarly, secant is hypotenuse over adjacent, and tangent is adjacent over hypotenuse. So if you can remember these three, then you just remember that they're that the cosecant you flip secant flip and cotangent flip. So now let's say we have a triangle with hypotenuse 4, the opposite side 3, and the adjacent side square root of 5. So let's find our six trigonometric functions. So sine of theta is opposite over hypotenuse. So that is going to be 3 over 4. Cosine is adjacent over hypotenuse. So that is square root of 5 over 4. Tangent is opposite over adjacent. So that's 3 over square root of 5. And then cosecant theta, that's hypotenuse over opposite. Secant theta is hypotenuse over adjacent. And cotangent of theta is adjacent over opposite. Let's try another example. Let's say that we are given that cosine of theta is 4 over 5. So if this is my angle theta, that means that the adjacent side is 4 and the hypotenuse is 5. So we don't know this side here. But what do we know that will help us figure that out? We have a right triangle on two sides, so we can use the Pythagorean Theorem. So that tells us that a squared plus b squared equals c squared, and those are the sides. So b is 4, a is what we're looking for, and c is 5. So we get 25 equals a squared plus 16. So a squared, we subtract 16 from both sides, equals 25 minus 16. So a squared equals 9. We take the square root, and a is plus or minus 3. But can we have a negative blank side? No. So a is 3. So we'll come back up here. We know that this side is 3 now. So now we're ready to determine the other trigonometric function values. So we have sine of theta is opposite over hypotenuse. So that is 3 over 5. We have tangent of theta is opposite over hypotenuse. So that is 3 over 4. And then for cosecant, we have hypotenuse over opposite, 5 over 3. Secant, we have hypotenuse over adjacent, so 5 over 4. And cotangent of theta, we have hypotenuse over opposite, which is 4 over 3. So now let's have you try one. Let's say you're given the triangle and you're told that cotangent of theta equals 1. So go ahead, pause the video, try this on your own, and when you're ready, come back to us. Alright, so we know that this is equal to adjacent over hypotenuse. But we may not know, but here we just have one number. So what this means is this is equal to, we can write this as 1 over 1. So from that we know both these sides are 1, so we use the square root. So we use the Pythagorean Theorem. A squared plus b squared equals c squared. So 1 squared plus 1 squared equals c squared. 1 plus 1 equals c squared. So 2 equals c squared. So square root of 2 plus or minus equals c, but we don't have negative length, so it's square root of 2 equals c. So now we're ready to find the rest of our sides. So let's start with tangent. We already have cotangent, so let's find tangent. Opposite over hypotenuse. That is 1. Let's find sine of theta. Opposite over hypotenuse is 1 over square root 2. Cosecant of theta is hypotenuse over opposite, so that's square root of 2 over 1. Cosine theta is adjacent over hypotenuse, and secant of theta is hypotenuse over adjacent, so that's square root of 2 over 1. So notice that because these two sides and these two angles are the same length, that sine equals cosine and secant equals cosecant. So where do you recognize these from? Hopefully if you've done the unit circle, you should recognize that this occurs when the angle is 45 degrees. So now let's look at some special triangles. So if we have a triangle whose two angles are 45, 45, and then we have sides 1, 1, square root of 2 like we just had. So this is also pi over 4. So that will give us special values of our trig functions that we need to remember. And then over here, if this is a 30, this is a 60, 30 triangle, well, let's say that this has side length 1. Then if we finish this to make it a equilateral triangle, so this whole thing now would be 60. Then this side is also 1. And equilateral triangles have equal sides, so this is 2 and this is 2. So now we have two sides of this right triangle. So we can use the Pythagorean Theorem. So a squared plus b squared equals c squared. A squared plus 1 squared equals 2 squared. A squared plus 1 equals 4. A squared equals 5. 4 minus 1 is 3. So a equals plus or minus square root of 3, but we don't have negative length, so a equals square root of 3. And so the trigonometric values of this triangle are also special values. And we should recognize them from a unit circle. This is pi over 3. And similarly, this angle, if we looked at it as this being theta, this angle is pi over 6.